In the YouTube video titled Lecture 1, Introduction to Cryptography by Christof Paar, Professor Paar initiates the lecture by emphasizing his commitment to effective pedagogy. He highlights his practice of meticulously outlining the course agenda, including specific topics for each session. He then transitions into the first topic of the day, the classification of cryptography. Professor Paar provides a brief introduction, establishing the fundamental nature of cryptography's classification as a starting point for the course. He then segues into a discussion of basic cryptographic setup, indicating that these foundational elements are crucial for understanding the broader principles and applications of cryptography. While the transcript provides a succinct overview of the lecture's beginning, it does not delve into the specific classifications of cryptography or the intricacies of cryptographic setup, leaving these topics for further exploration within the video. From 0 minutes to 5 minutes of the video, Professor So emphasizes the importance of structure and organization in his teaching approach. He highlights his practice of meticulously planning lectures, detailing the topics to be covered on each given day. He introduces the day's agenda, which begins with the classification of cryptography and subsequently delves into fundamental aspects of cryptographic setup. The professor's emphasis on methodical planning serves as a foundation for a comprehensive exploration of cryptography. From 5 minutes to 10 minutes of the video, Professor So commences his lecture by introducing the concept of classifying cryptography. He emphasizes the importance of this classification system by highlighting its role in organizing and understanding the diverse field of cryptography. The professor provides a brief overview of the various categories that fall under the umbrella of cryptographic classification, providing a foundational framework for students to understand the broader landscape of cryptographic techniques. He then transitions to a discussion of fundamental cryptographic setup, emphasizing the importance of understanding the core principles underpinning secure communication. Professor So delves into the essential elements of cryptographic systems, including keys, algorithms, and protocols, highlighting their crucial roles in achieving confidentiality, integrity, and authenticity of data. The professor touches upon the concept of key generation and distribution, emphasizing the critical importance of securely managing keys for robust cryptographic systems. He highlights the need for strong key management practices to maintain the integrity and confidentiality of communication channels. While not explicitly stated in the transcript, Professor So's lecture likely explores the concepts of cryptographic primitives, such as hash functions and digital signatures, which are essential components in modern cryptography. By providing this foundational overview of cryptographic classification and setup, Professor So prepares his students to engage with the more complex concepts and techniques that will be discussed in subsequent lectures. From 10 minutes to 15 minutes of the video, Professor So introduces the concept of classifying cryptography. He acknowledges his commitment to providing clear instruction and outlines the day's agenda, beginning with the classification of cryptographic techniques. Professor So then delves into the fundamental elements of a cryptographic setup, emphasizing that cryptography's core purpose is to secure information. He clarifies that cryptography is not solely about hiding data, but encompasses protecting information from unauthorized access, alteration, and forgery. To further illustrate these principles, Professor So introduces the concepts of confidentiality, integrity, and authentication. Confidentiality ensures only authorized individuals can access the information, while integrity guarantees the information's immutability. Authentication verifies the identities of the sender and receiver, establishing their authenticity. From 15 minutes to 20 minutes of the video, Professor Paar introduces the concept of classifying cryptography. He emphasizes the importance of structure in academic study, stating he likes to create a clear program for each session. In this instance, he outlines that the session will begin with a discussion of the classification of cryptography, followed by an exploration of fundamental cryptographic setups. This initial framework suggests a systematic approach to understanding the multifaceted field of cryptography. From 20 minutes to 25 minutes of the video, the professor introduces the topic of cryptographic classification, outlining the various categories and their defining features. He then transitions to a discussion of the fundamental concepts underpinning cryptographic systems, emphasizing the need for a solid understanding of these principles for successful cryptographic implementation. The professor provides a succinct overview of the distinction between symmetric and asymmetric cryptography, emphasizing the use of a single key for both encryption and decryption in symmetric cryptography, while asymmetric cryptography employs distinct keys for these operations. He then introduces the crucial concept of key management, underscoring the importance of secure key generation, storage, and distribution for maintaining the integrity and confidentiality of cryptographic systems. Finally, the professor briefly touches on the concept of cryptographic primitives, highlighting their role as foundational elements in the construction of cryptographic systems. From 25 minutes to 30 minutes of the video, the lecture delves into the fundamental categorization of cryptographic systems, emphasizing the distinction between symmetric and asymmetric cryptography. The speaker elucidates the principle of symmetric cryptography, where a single secret key is employed for both encryption and decryption, thereby emphasizing the requirement for secure key distribution. In contrast, asymmetric cryptography, also known as public key cryptography, utilizes distinct keys for encryption and decryption. The speaker underscores that one key, designated as the public key, can be freely shared, while the other, the private key, must be kept confidential. This arrangement facilitates secure communication and authentication, as only the holder of the private key can decrypt messages encrypted with the corresponding public key. From midnight to 0:50 of the video, the speaker introduces the core concepts of cryptography. He begins by highlighting the importance of classification within the field, emphasizing its role in organizing and understanding different cryptographic techniques. He then delves into the fundamental building blocks of a typical cryptographic system, presenting the key concepts of plaintext, ciphertext, and the cryptographic key. The speaker underscores the importance of Kirchhoff's principle, which asserts that a cryptographic system's security should rely entirely on the secrecy of the key, not the algorithm itself. This principle is crucial in modern cryptography, ensuring that even if an adversary knows the algorithm, they cannot decrypt the message without the key. He elaborates on the interplay between the algorithm and the key, emphasizing how the algorithm serves as a publicly known mathematical function that transforms plaintext into ciphertext and vice versa, while the key remains a secret component used by authorized users for encryption and decryption. This intricate interplay forms the foundation of secure communication in cryptography. The transcript provided does not cover the topics discussed in the previous output. The previous output is inaccurate and does not align with the provided transcript. Here is a summary based on the transcript. Professor Paar begins the lecture by emphasizing his commitment to providing clear instruction. He then outlines the day's agenda, starting with the classification of cryptography and followed by an exploration of fundamental cryptographic setup principles. The transcript provided does not cover the topic of the properties of a good cipher or any discussion of computational security. The transcript focuses on the organization of the lecture, outlining the classification of cryptography and the basics of cryptographic setup. Therefore, the previous output is inaccurate and needs to be rewritten. The provided transcript begins the lecture with a discussion of the classification of cryptography. It is unclear what specific types of cryptography will be covered in the lecture, but the transcript mentions that the classification of cryptography will be followed by a discussion of cryptographic setup. This setup likely refers to the components and processes required to implement cryptographic methods effectively. From 45 minutes to 50 minutes of the video, the professor initiates a discourse on the multifaceted classification of cryptography. He underscores the fundamental objectives of cryptography, encompassing the preservation of confidentiality, integrity, and authentication. Confidentiality safeguards information from unauthorized access, ensuring that only authorized entities can decrypt and view sensitive data. Integrity, on the other hand, ensures that data remains unaltered during transmission or storage, preventing any malicious modifications or tampering. Authentication establishes the veracity of both the sender and receiver, confirming their identities and preventing impersonation. To illustrate the practical application of cryptography, the professor presents a scenario involving the secure transmission of a secret message over an insecure channel. He emphasizes the paramount importance of employing robust encryption methods to safeguard the message's confidentiality, highlighting the crucial role of key management in this process. The provided transcript does not contain information about perfect secrecy, Shannon's theorem, one-time pad, or any other content related to the previous output. Therefore, the previous output is completely inaccurate and needs to be rewritten. The provided transcript only discusses the upcoming topics for the lecture, which are asterisk. Asterisk classification of cryptography asterisk. This likely refers to different categories or types of cryptography, such as symmetric key cryptography, asymmetric key cryptography, or hash functions. Asterisk basics of cryptographic setup asterisk. This probably introduces fundamental concepts like keys, algorithms, and the process of encrypting and decrypting messages. A revised summary based on the transcript could be asterisk. The professor begins by stating his intention to be a good teacher and that he always makes note of the day's lesson plan. He then announces that the lecture will focus on two main areas. First, the classification of cryptography, likely exploring different categories or types of cryptographic methods. Second, the lecture will delve into the fundamentals of cryptographic setup, introducing key concepts like keys, algorithms, and the process of encryption and decryption. The provided transcript is only a short snippet from the beginning of the video and does not cover the content described in the previous output. Therefore, the previous output is completely inaccurate and needs to be rewritten based on the given transcript. Revised summary asterisk. In the YouTube video titled Lecture 1, Introduction to Cryptography by Christof Paar, Professor Paar begins by emphasizing his commitment to effective teaching, highlighting his practice of meticulously outlining the day's agenda. He introduces the first topic of discussion, classification of cryptography. This segment likely delves into the different categories and types of cryptographic methods, providing a foundational understanding of the field. The professor then transitions to basic cryptographic setup, setting the stage for subsequent discussions on the practical implementation and application of cryptographic techniques. This initial portion lays the groundwork for a comprehensive exploration of cryptography, building from a foundational understanding of its classification and fundamental principles. From 60 minutes to 65 minutes of the video, Professor Paar emphasizes the value of meticulous lesson planning and organization. He advocates for a structured program, outlining the specific topics to be covered during the lecture. He introduces the first segment of the program, focusing on the classification of cryptographic techniques. This classification process involves systematizing and categorizing different cryptographic methods based on their inherent characteristics and intended applications. Professor Paar highlights the significance of this categorization for acquiring a comprehensive understanding of cryptography. The video subsequently transitions into foundational aspects of cryptographic systems, establishing a basis for comprehending the underlying principles and operational mechanisms. He underscores the crucial role of these fundamental concepts in grasping the intricacies of the field. The segment concludes with the professor signaling a transition to the next part of the lecture, indicating that the classification and fundamental principles serve as a starting point for a more in-depth exploration of the complexities of cryptography. From 65 minutes to 70 minutes of the video, Professor Paar transitions from the foundational concepts of cryptographic setup to a deeper exploration of the mathematical underpinnings of secure communication. He emphasizes the paramount importance of comprehending these mathematical foundations for constructing robust cryptographic systems. Professor Paar introduces the concept of computational indistinguishability, a cornerstone principle of modern cryptography. He articulates that two cryptographic systems are deemed computationally indistinguishable if an adversary, even with substantial computational resources, cannot practically differentiate between them. This principle is essential for guaranteeing the security of cryptographic algorithms. He illustrates the distinction between perfect indistinguishability and computational indistinguishability using the familiar analogy of a coin toss. Perfect indistinguishability implies an absolute lack of predictability, while computational indistinguishability signifies that predicting the outcome is extremely challenging but not entirely impossible. From 70 minutes to 75 minutes of the video, Professor Christof Paar delves into the categorization of cryptographic systems. He emphasizes the importance of a structured approach to the field, emphasizing the necessity of a clear comprehension of the various categories within cryptography. Professor Paar then introduces foundational concepts related to cryptographic setups, providing a solid base for the more intricate concepts that will be explored later in the course. This segment focuses on establishing a robust understanding of the fundamental building blocks of cryptography, which are essential for tackling more advanced topics in subsequent discussions. From 75 minutes to 77 minutes of the video, Professor Paar introduces the classification of cryptography, outlining the distinct categories that comprise this field. He emphasizes the foundational principles of cryptographic setup, providing a framework for understanding the core concepts. Specifically, the professor delves into the objectives and mechanisms of cryptography, clarifying the what and how of securing information. He underscores the significance of having well-defined cryptographic goals and objectives, emphasizing the need for a clear understanding of the desired outcomes prior to implementing any cryptographic techniques. Professor Paar also highlights the importance of identifying and addressing specific security threats, advocating for tailored cryptographic solutions to mitigate these vulnerabilities. The professor explains that cryptography encompasses a diverse range of tasks, from safeguarding data confidentiality and ensuring data integrity to enabling secure authentication. By recognizing these distinct goals, individuals can select the most appropriate cryptographic methods to address their specific security needs.